Let's look at a kinematics example. And we're going to look at kinematics constant acceleration. And so let's make a little curve here, velocity versus time. And let's suppose the curve looks something kind of like this here. And we'll call the final point here t. And we'll call the velocities, it'll be the initial velocity, and then this one, the top, will be the final velocity. Now if I want to find the total distance, the total displacement that this object does, the best way to do that is do the area under the curve. And so here I have two pieces for area under the curve, 1 and 2. For the first one, I can write as 1/2 v final minus v initial times that t. Note this right here is your average velocity. And then I also need to add in the second part, which would be vi times t. Now together, if I add these up, I'll end up with 1/2 v final t minus 1/2 v initial t plus v initial t, and you end up at the end with 1/2 v final plus v initial t. This is actually a kinematics equation that some books actually derive and use. It's sort of the one that not everyone does, but you can use this. But just note that this idea here, this being the velocity average, this will work only if the initial velocity is 0. If your initial velocity is not 0, you cannot just use this part of the equation.